Hey folks, welcome back. So last episode we after a lot of back and forth and debugging my code, we got the tree to now spawn its pickup actors. And what we're going to do is we're going to quickly just test these two, see if we can get gravity and physics to work on them. Simulate physics, enable gravity. Not going to worry with any of this other information for now. And we want this to be, let me get that system information out of the way. We want that to be all defaults there. So close that out of that. We're going to try this again. There you go. You can see they now fall, they roll, and they are now physics enabled. However, we have a flaw in our logic. We're infinitely spawning. So we're not setting our little flag somewhere. So, as this is a direct follow on from the last episode, let's go through and let's take a quick look in here. So, on take damage, because this is what we're calling, actually, I'm going to hop back here. We're going to open the blueprint quickly. So, we're going to open the tree blueprint. On component begin overlap, this is why. We have no check in here. We're just saying take damage. If we go into here, we're just saying if it doesn't have the tag, don't do anything. So we need to make a check here. Or health less than or equal to 0. And the reason for this is the stump component is already is going to be able to continue to take damage. And we actually have a better way to do this. So we've got our harvest function here. I just realized this, we have a different way we can do it that we don't need to do any math. The harvest function, if we call that, we'll step up and take a look at what we're doing there. We're setting B is harvested is true. We're going to copy that, or B is harvested. That's all we need to do. So what we're saying here is if it doesn't have the harvest tag, or if it's already harvested. Now, we do have a different way. I'm going to flip this around actually, but I want to explain why. So we're going to just cut this out, get rid of this, go to the front. So this is going to be down to how the order of operations works with C++ programming. Because this is an if either of these conditions are true, we're going to drop into here. What's going to happen is we're going to check B. It's going to check B is harvested first. If this is true, it's not going to check this. It doesn't need to because this is already true. So we're going to go through. So this is a minor refactoring you can do that's going to help improve performance. We don't need to worry about any of this because that's true. So hop back into the editor. We don't need to worry about this. Close out of that. We're going to do just a live code compile. Constantly opens up on my other screen. I'm going to move that over. That has finished, so let's try this again. So we'll walk forward, things fall down, we'll walk back, walk forwards, and you can see now it's only happening once. We no longer have an infinitely harvestable tree. And like I said, so with that, this capsule component or sphere component that we have that we're just using for a simulation to dev test this is not something we have to worry about. But that take damage function, which is where the root cause of the duplicate value was, or the duplication was, still actually applies to this stump. So you can hit it and it would continue to execute that function even though there's nothing there. So One thing I want to do is those logs look a little puny, so I'm going to drop out of there. We're going to open up the... I'm going to set these to twice the size, viewport, compile and save, close out of there. So I want to run this quick because those logs looked a little puny. Oh, I know why. Because we have, let's open up the tree actually. Let's try those. That might make a difference because we're using those transforms. There you go. You can see they're bigger. With that, you will need to adjust these transforms because, as you notice, there was some collision. And that is where you end up with what I like to call Bethesda physics, where you'll see things launch into space. So just quickly on that one, let's open up the tree again, and we're going to bump you up to 200, and we're going to change you to 350. Let's see how that works. Compile and save. Let's move that out of the way. Try this one more time. Nope, that's still pretty crazy. So let's bump these up to location 200 and 500, or 250 and 500. Compile and save. Try this again. There you go. You can see they had relatively useful physics and it just collapsed straight down. Now, we don't have any interaction in place yet because... why is our interaction not actually? So we should... is the trigger over here? Okay, trigger's there. And what are you? Those aren't triggering our interaction text. So we're going to do a little more debugging there. At this point, though, because we have done that live coded, I do want to close out of the editor. So we're just going to close out of our tree, close out of the editor, and close out of our live coding. We now know this is working, and add a root component before we start adding multiple variants of trees, multiple logs, things like that. We know this logic we have here is sound. I say sound. It's got some it's stable. There's nothing we need to change with it at this point. So I had to think of the right terminology here. So I'm going to clean up the comments. We know we don't need this anymore. And I did have a comment that was throwing the spawn actor here between the onHarvest BP and the set harvest state, and I'm actually going to follow through and intend to put that, well, put it where it was intended. So we now have all of that in place. We can close out of our tree base. We don't have to worry about anything in there. We can actually close out of all of these other files for now. We're going to want to go into the player character because I want to look into the interaction logic, why the logs aren't spawning. So trace for interaction, get world. So didn't actually need to close the editor, but we have this particular one here. That was that debug trace we were doing. And we had added the debug Boolean to turn that on and off. I just want to step through this quickly because it's been a few episodes since we looked at this. Well, it was only started in episode 10, so it's not been that long. But anyway, so we're doing our trace, line trace. If it's not a blocking hit, interaction LT, trace for interaction, update interaction text, calls the blueprint one. me just find all in current document just to, where are we calling that? Okay, it's called right before we do that. So it means the first frame that's going to fail, that's not going to have anything, but the second frame it is. So, okay, let's just launch back into the editor. We're going to build. It's going to take a moment because we do have that minor code change we made. However, as you can see, that built very quickly. And the editor is launching fairly quickly. So, let's launch, play an editor. And I know I did mention in the last episode that we were going to also look at a harvestable actor. I do intend to get to that, hopefully. Player. No, character. Character. All right, and then debug. Debug show interaction trace. Okay, so you go there. Interaction trigger. Turn that on. Okay. All right, so now, yeah, we should line trace. All right, let's F8 to jump out. Actor, log pickup. Interaction actor, yeah, log pickup 1. All right. So we're going to go into our player character blueprint. Okay, let's just open up player character blueprint here. And what are we seeing here? Interaction text returned null. Okay, we're going to stop there. We're going to open up our log pickup. What did we call that variable? Pickup actor. Interaction text. We should be getting a default. What did we miss in the code? Get interaction text implementation. Are we calling something different? Is that why this isn't working? What is not working here? That should be showing default. What have I messed up? So, go through. I'm going to hit the... Alright, pull this back over. Okay, so we've hit this. The target is the BP log. Can we step into that? No. Returned a value of null. So we're going to step into that. Why is it? I think I know why. Let's go back to here. Okay, so that is... okay, so it's working on the door. Let me just... Where's content browser gone? There it is. Pull that over quickly. We know it works on our door. So let's take a look here. Get interaction text. We're doing it at a C++ level, but it's using the blueprint interface. That's why. Oh, I am really not with it. So open full blueprint editor. Interface. Get interaction test. We need to create that. So pick up log. change anything. We're going to save. Don't need anything there. Compile and save. Close out of this. Move the content browser. And hopefully this time we should actually see pickup log. And it's going to throw a breakpoint. But yeah, let's turn that off. Continue. Move this out of the way. Come on. There we go. So this is where we're going to be doing some refactoring on the interaction interface, just because I realized I have made some mistakes on how we implemented that. However, I'm going to be doing that in another episode, just so that we can keep things moving along here. So pick up log. And now this is actually something else that you're going to run into. You can fix these so that it's not permanently interactable like this, or you can leave it like that. That is entirely up to you. However, we have got our basic tree set up. Now let's just check something. I'm going to go to save. Actually, I'm going to save it over here. I don't want to be inside the collision area to start with. So save. I'm going to load. Do not call this function. What are we called? I thought I fixed all of these. Update from save. Continue. Yes, I know. Okay, so that's work. Not sure. Now we're going to load because we saved. And we're running into that issue. Contract. We're there. The harvest state and the logs are missing. So we are going to need to work on that. I'm going to move that into a separate episode though. That'll actually probably be the episode after this one, some general project cleanup. However, I'm going to leave that for now, because this is also something you're going to find you're going to have spent enough time working on a particular thing that you end up, well, as they say, beating your head against a wall. When you reach that point, like I did, in this double episode recording, I'm a little frustrated with this tree, and it's just creating a harvestable tree. But when you reach this point, don't keep pushing. You're just going to keep making mistakes. You're going to get more frustrated, and you're going to basically want to say, screw it, I'm done. It's not a good situation to be in. Thankfully, at least for myself, because this is a solo project, I have 100 different things I can work on. Hopefully, if you're in a similar situation where you're working on a particular chunk of code, chunk of blueprint, whatever it be, that you hit that frustration point and you say you're done, you do have the ability to hop over to something else. So, with that, I'm going to move us over to that harvest actor I was talking about. So, we're going to go to our C++ classes, project file, public, base classes, and again, we want to derive it from the TF actor. We're going to create a class derived from TF actor, TF harvest actor base. And yeah. So now there is one thing we could have done here. We could create a derived class from TF actor, which is TF interactable actor, and use that to then derive from the tree and the interaction interface. However, I'm going to have a lot more items I want saved than I want interactable. That sounds weird. So I want to try and limit, like, you could have, in theory, an infinitely long chain of parent-child classes, and that's perfectly fine. I personally try to limit that wherever possible. In this case, because we are creating so many derived TF-actor classes that are using our interface interaction interface, it may actually be worthwhile. If we get any more, I might, but right now I've decided against doing that. And if we do, that will be a good episode to cover reparenting a class within an Unreal project. So with that, we've closed out of the editor. We're going to hit reload. And we now have our harvest-based actor. So this one, it's going to be somewhat similar to our pickup actor. We're going to start in our header class. And we can actually have a copy-paste of these particular items here. Grab those. We're going to copy over those items. We are going to also need to copy over our interaction interface header for our includes. And along that same front, we're going to copy these, paste them in, and give this the interaction interface. Don't need the semicolon. So there isn't a huge amount that's different over this one, except we need two different static mesh components. They could be skeletal mesh, depending if you're going to have animated objects that use a skeleton. But in my case, I don't intend that. So what I do is I change, well, I call one of them the permanent mesh. And then I'm going to duplicate this basically and go call this the harvest mesh. Harvest mesh. English I find hard sometimes, even though it's my first language. So just to quickly cover these two items. And actually there's going to be, I'm going to do this fix now. U function blueprint callable. I'm going to copy that. I'm going to add that to our tree base, because that's what the issue was, is this particular function wasn't blueprint callable. And we did add the am I on the tree base? No, I'm a pickup actor. I'm in the wrong one. We did add the get interaction text of return interaction text. We need this to be the return for the blueprint version. So, and that's ultimately what our issue was there, is we didn't have those two connected and we couldn't actually do it because it's not blueprint callable. Anyways, so in our harvest actor, we have our permanent mesh and our harvest mesh. Just to explain what those are, the permanent mesh, let's take a berry bush, for example, or Skyrim mountain flowers. They have a two-part mesh. They have the permanent mesh that is always there, whether you can harvest anything from it or not. And then they have the colored mesh, the berries, or in the case of the mountain flowers in Skyrim, the red, blue, purple actual petals. And that would be the harvest mesh. So the permanent mesh is if something is always going to be there. The harvest mesh is if it's harvestable, then it's showing. If it's not harvestable, we hide it. And that's going to be the function here. There is a couple other things. So what we're going to do is actually I realized I think our problem with the tree and the pickup mesh is we don't have the save game tag on those. So bool b is harvested equals false. That attribute is what was missing. So now we do want to add these definitions. So, interact, which one am I missing? Is interact, well, I thought I just defined that. No, obviously not. So, there we go. So, this one is going to have some logic to it. So, is harvestable or is harvested? Is harvested. B is harvested. So if it is harvested, we want it to say it's false. And if it's not harvested, we want it to say it's true. And here we're going to do the same. Return interaction text. And interact implementation. So this again is going to be similar to our pickup actor. So I'm just going to copy this code here. And we're going to throw that in there. I can't really call that code. I'll copy this comment. However, we don't want this equals destroyed because it's not removing it from the world. What we want to do here is harvest mesh. Actually, I'm going to put a break in these comments. Set static mesh null pointer. So what this is doing is it's basically going to clear the mesh. Actually, did they add a function for that? Maybe they did. Create mesh height. Set static mesh. No, they didn't. Okay. And actually, that's not what you want to do, because if these are regrowable. So, harvest mesh. Hidden in game. Equals true. So, what this is doing, again, I'll run through this. Pretty basic. Most of this is going to be left until we get to the inventory component, which is going to be next episode. This one thankfully hasn't taken that long. So, but what this is, basically we're grabbing the inventory component of the caller. We're going to see, okay, can I add this number of items to your inventory? If we can, we're going to hide the harvest mesh because obviously it's been harvested. And then one of those B is harvested equals true. And then we're going to return because we don't need to do anything else. If it's not, we're going to say, okay, there was 10 berries. It's now 2. Hypothetical. And then we're going to return. We're not going to hide the mesh or anything like that. Now, there is the ability to add regrowable mesh, harvestable. So what we're going to do here is build a project. Why are you not saving? Build the project again. And hopefully this builds pretty quickly. Yeah, it's built fairly fast. We're going to launch the editor because the next thing we're going to do as just a secondary component to this harvest item is a regrowing harvestable item. So I'm trying to think of an example. Well, let's take a berry bush. Like in the real world, it gives berries every year. Fruit trees do that, things like that. So a regrowable item would be something that represents that. It's not one and done. It's okay, it happens every 360 days or however long you want it to be. And that is going to be dependent on your game with your needs. your game's needs. What I'm going to do here, though, is we are back in our C++ classes in our base class folder. We're going to right-click the harvest actor, create a C++ class derived from that. TF regrowing. Get my casing correctly. So regrowing harvest actor base. There is not much difference between this class and the parent class we just created of the harvest actor base. I'm actually just going to reload. It's going to say, do you want to stop debugging? Yes, because we're done in the editor. We're not saving anything there. Let's get rid of a lot of these. Clean it up. And we have the header. I want the source file. So in here, we actually want to change the state of these from private to protected. Protected, if I could spell. The reason being is, well, actually, this doesn't need private. Not all of these need to be protected. So the permanent mesh, we don't need to be protected because we're not going to be calling anything from that in the in the regrowing. We do need the harvest mesh to be protected so that we can access it from the child class. We do need is harvested. The inventory item doesn't need to be. The item count we do, because let's take again the regrow, the fruit tree. At the start, when the first fruit, or the berry bush, however, at the start of it, when the first berries are showing, there's only one or two. And then at the end, there is more. So we want this to be edited or modified, reachable by the regrowing class. And then, why did you all of a sudden start throwing errors? This all worked until I did that last copy paste. Yeah, I'm just gonna move that back up there. We want that to be protected, and we don't need that to be protected because that's not going to be a code change. Okay, so let's build that and see what happens. This should all just build. For some reason, it's saying it can't read core minimal. So there you go. Again, this is something that happens periodically with Unreal Engine. I think I mentioned it before, but it is where is it? Integration logging. It's parsing stuff. It's trying to do some back-end things while you're working. So, but anyway, so now that we've got these adjusted from the private variables, because we don't need to do anything to them, and the protected variables that we need to have access to our child classes, we can go into our harvest actor base. Actually, I'm just going to close out of that, and I'm going to move this over just off to the screen just so I can keep reference to these guys quickly. So in here, in the private section, we are going to add, and this is sort of why I wanted it to be able to grab these U properties quickly. We're going to add a U property. We want this to be float int. So this is something, I'll just cover this before I go into it because it's going to be how I'm doing it for my game. This particular approach I'm using, it's going to be based loosely off a per tick style. Once we get through, and it was actually an option for the next big project, but once we get to the chrono manager, and that's going to be things like passage of time, I'm going to be having some delegates in there for for time change. And so this is going to be an int number of days to regrow. And I'm just going to start off with 1. And then we want to also in here have a constructor for this one, because we're going to need that. Add that in there. And then, begin play. I can never remember if that has to be public or private. I believe that's public. Or is it protected? Oh, it's been so long since I've looked at begin play as well as in case of adding it to something that didn't already have it. It's protected. Okay. The IntelliSense not working is annoying me, but oh well, gotta live with it. So we're gonna go to our source file and just add this in. Okay, so anyway, so to explain this, we're gonna have a multicast delegate, excuse me, that is going to be coming from our chrono manager, and that's going to say time has changed, and it's going to have a couple of different ones. My intent there is to have its minute, hour, day, and year. And then from that, anything that needs to know can go to a granular level as needed. For something like a harvestable plant, you do get certain things that have the potential for a multi-year harvest. Like you can get it, multi-harvest per year. That you can basically gather the items off at 2-3 times a year. So that's why I've wanted to go for number of days to regrow. And then from that, once we've got to the chrono manager, I'm going to be adding a to-do in here in a moment, but shall do that right now. To-do, subscribe, to day change delegate. So with that, we need a public function void on day change. And the other thing we need, and it's going to be up here, it's a private variable. I'm going to add it to the top here. We don't want it edit by default only. We want this just to be visible anywhere. Visible anywhere. And the reason being is we want to be able, see this, but we don't want to be able to change it. And this is also going to be save game, because that's going to be adjusted per instance. Int days since last harvest equals 0. So we're going to on day change, we're going to create that definition. And this function basically is when we subscribe to the delegate and we get that, this is going to be what we are executing. The delegate itself is likely going to have several parameters that are part of it. Let me just pull over an example of what I had. It's going to go new document. No, not a new project. Actually, I'm just going to post it down here. So this is an example of the delegate I was using previously. I do want to do some changes to this because this was just a single delegate that was being used for everything. And I found that it was horribly inefficient, that if you needed once a year fidelity, you were getting updates every minute. If you needed once a month fidelity, you were getting updates every minute. And this is minutes in game time, not minutes in real world. So we're going to be having more than one delegate for time changes. So what will be happening though is this function will be called. So, and this logic is pretty simple. It's going to be days since last harvest plus plus, and I need to learn to spell. So right click on the declaration, rename that, and fix it. Now the reason why I use the declaration and not referencing from the source page is this is like in the header file, that is saying this is the variable. Whereas in the source files, it's, oh, I'm talking about that variable over there. So, but you can see we only had one reference to it. That's not a problem. Back in our source file, days since last harvest, apparently it didn't fix it. Days since last harvest, days since last harvest. Okay, so we're going to save everything. And then if days since last harvest, for safety's sake, ideally you could just put equal to, but greater than or equal to, oh, and I forgot what we called it, number of days to regrow. Number of days to regrow. Then we want to regrow. Simple as that. Now, ideally, I would recommend you move this into its own function. And that's how I'm going to do it here. You could add in all of your regrow logic in this section as well. And actually, I'm not following my own convention. What we want to do here is less than number of days to regrow, return. And then we want to do regrowth logic here. So what we're going to do is in a private function, and this is the reason why I recommend moving into its own function, is we want it to be its own private function, not something that is available to be called by external actors. Void, trying to think how we want to word this, reset harvest. Create a definition for that, and we have it up here, and we are just going to quickly copy paste that down here. Now, as I had mentioned, you do have the potential for we're gonna get that harvest actor base up over here again. You do have the potential for increasing the increasing the number of items. So I had to think the terminology I wanted to use here. Increasing this amount over time. And you can do that. I'm actually not going to cover that in this episode. I don't know if I'm going to cover that in detail at all. I can't think of anything I've currently got planned that would require long-term growth. Or sorry, not long-term growth, but a exponential growth. That's the word I was looking for. So I may cover that later in the series, I may not. But anyways, so what we're going to be doing here with our reset harvest, it's going to be B is harvested equals false. And this is where we actually need to have a second variable to represent this item count, and then we need to add in, man, I've made a mess of this file. int item regrowth amount equals 1. And that's a visible. I need to make that a default only. So over here, item count equals item regrowth amount. And then harvest mesh hidden in game equals false. And then, just because we had that issue with our tree actor, we need to call mark component render state dirty. And what that is going to do is cause it to re-render and show that harvest mesh. So, with that though, folks, this episode has hit my normal episode limit. It's 45 minutes. What I am going to do is I'm going to leave things off here. Next episode, I will be covering just the very basics of the visual side of this. And then we will be moving straight into the interaction into the inventory side of things. Now, the inventory side is going to be a fairly long number of episodes. I'm not sure exactly how many, because it does involve, well, a lot of classes. It's not a very simple process. Taking a look at my last round of work on an inventory, well, I think I got close to 1,000 lines of code. So, anyways, I digress. Next episode, we will be going into the inventory system. We're going to be starting work on that. And following that, I'm not sure what'll be up next, but the inventory is going to be taking us a while. So, with that though, folks, thanks for watching until the end. I hope you enjoyed. As always, any comments, questions, suggestions, feel free. I understand I'm not a perfect game dev. There's going to be things here I got wrong, as I proved with the pickup actor spawning here in the tree. I've never used that method of spawn actor using a template. So, you learn something new every day. With that though, folks, thanks again. Hope you enjoyed, and I will catch you in the next episode.